All right, so now we are going to talk about fundamental identities, trig identities. Okay, so here they are. Tangent is sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent, or cosine over sine. All right, here's how I remember them. Tangent being sine over cosine, you just kind of have to remember. Okay. Secant, look, secant and cosine, this looks like kind of they're backwards. C vowel S, C vowel S. To me, that makes sense. Cotangent and tangent, to me, are linked in my mind. And cosecant is the other one. Okay, I don't know. It doesn't look anything like sine. Okay, but secant and cosine in my mind, I can link together pretty easily because of the letters that are in the abbreviations. Okay, and so we kind of have been using these already. We were thinking in terms of x's and y's, but really these identities we're going to use a lot this semester. All right, so let's use these identities to evaluate the trig functions. So if we're given that sine of 45 is square root of 2 over 2 and cosine of 45 degrees is square root of 2 over 2, which we could have figured that out already, right? We figured that out in the last section. We didn't need them to tell us that. To evaluate tangent, okay? So let's do that one first. Well, tangent is sine over cosine. So sine of 45 over cosine of 45, square root of 2 over 2 over square root of 2 over 2. It's just going to be 1. So tangent of 45 degrees is 1. How about this one? If they tell us that sine of 5/6 is 1/2 and cosine of 5 pi 6 is negative square root of 3 over 2. Notice we also could have figured these out using reference angles, right? The reference angle for this would be 1/6, right? And this is in quadrant 2. And in quadrant 2, sine is positive, cosine is negative, right? We could have figured that out. Evaluate secant. Okay, well, secant is 1 over cosine. So it's going to be 1 over cosine of 5 pi 6, which is 1 over negative square root of 3 over 2. We get negative 2 over square root of 3. We rationalize the denominator to get negative 2 square root of 3 over 3. Okay. Well, how about this? If we just want to simplify secant over tangent, how can we do that? Well, it would be easiest to write each of them in terms of sines and cosines. So we can say, well, secant is 1 over cosine, and tangent is sine over cosine, right? And now I'm going to invert and multiply this denominator. So I have 1 over cosine times cosine over sine. And I can cancel the cosines and just have 1 over sine, which is cosecant, right? So just as a side note, we kind of have created another identity. Cosecant is secant over tangent. I would never remember this. Okay, you don't have to remember this. You really just have to remember those fundamental identities, and then you can rearrange things and you do some simplifying like this to find new identities if needed or your textbook asked you to. All right, Pythagorean theorem, right? We talked about this last time. Cosine squared plus sine squared is 1. Always works. Okay, well, what happens if we multiply all of the terms by cosine squared? Okay, divided by cosine squared, divided by cosine squared, divided by cosine squared. Well, what do we get? This is just 1. Sine over cosine is tangent, right? So we get 1. This is tangent squared, and 1 over cosine is secant. So here is another form of the Pythagorean theorem. I am not good at remembering equations. Maybe you are, and you can remember this. I just remember this one and then divide through by cosine squared if I want to figure out what this is. What if we do the same thing with sine squared? Well, cosine over sine is cotangent. This is going to be 1. And this is going to be 1 over sine is cosecant, right? So cotangent squared plus 1 equals cosecant squared. So these are the two alternate forms of the Pythagorean theorem. Like I said, I don't remember them. I just remember this and divide through by cosine squared or sine squared. Okay. All right, so let's use this. What if they tell us cosine of this angle T is 12/13, and it's in quadrant 4. Find the other 5 trig functions. Okay. Well, in order to find, we really need to know sine and cosine to be able to find the others. So if I just know one of them, I can use the Pythagorean theorem, right? I know that cosine is 12/13. So 12/13 squared plus sine squared is going to equal 1. So I want to solve for sine squared. So bring this to the other side, do the math, take the square root, figure out, and then simplify this, right? It's 5/13. That's why they use the squared number. And now, is it going to be positive or negative? Well, sine in quadrant 4, remember A, smart trig class, sine is negative here. Also, the y value is negative, right? We can see it's down here on the y-axis. So it's going to be the negative, sine of t is going to be negative 5/3. So once we know that, tangent is sine over cosine. We get negative 5/12. Secant is 1 over cosine. There we go. Cosecant is 1 over sine. Cotangent is 1 over tangent. Right? So once we know sine and cosine, we can easily find all the others using those ratios, using the fundamental trig identities. Find the values of this trig, of the 6 trig functions based on this figure. So you're noticing these are all kind of the same question asked in different ways. Okay, well, here we are. We know the x and y values. So we know cosine and sine. Sine is negative square root of 3/2. Cosine is negative 1/2. Once we know those, we use all of these, the fundamental trig identities to find these ratios, simplify things, rationalize denominators, right, to get these different values. How about this one? Don't have a figure or drawing this time, but they tell us what sine is and they tell us what cosine is. So we're going to use the fundamental trig identities. So secant is going to be 1 over cosine, which is 2. Cosecant is 1 over sine. Get this. Tangent is sine over cosine. Cotangent, 1 over tangent. Okay. All right, the one last thing we want to do is, what if you want to find the cosecant of 5π7? 5π7 is not something that we know. We don't know sine of 5π7 or cosine of 5π7. So we can't use reference angles. It's not going to be on any of the tables. It's not an angle that we know. We have to estimate it using our calculator. So if we look at our calculator, grab your calculator now, and see if you can find the cosecant button. It's not there, right? No calculators have a cosecant button. So you're going to have to use the trig identity that cosecant is 1 over sine. Okay? So you are going to, so make sure you can get this number, 1 divided by, and I don't know why they do this in this order, find sine of 5π7, and then it's 1 over that number, right? So it should be 1.279. Make sure you can get that in your calculator. For these other, so you should have a sine, cosine, and tangent button, but you don't have a cosecant, secant, or cotangent button. You have to use the fundamental trig identities to find those values.